should see that the equation for kinetic energy of the mass m, that is this one, okay, and the kinetic energy of this mass of the pulley has to be written, and the potential energy of the spring has to be written, and they have to be put in the equation. The first equation, that is kinetic energy plus potential energy is equal to constant, and it should be differentiated. Later, after differentiating, okay, compare it with the standard equation and find out the value of omega n. Any doubt? Any doubt are there? So you can clear your doubt and proceed to next problem. So, and one number, what is that? When the mass is displaced by distance of x, so here also this pulley moves by an angle theta. So how much distance it has travelled? So that is what x equal to r into theta. What is r? R is the radius of the pulley. Capital R is the radius of the pulley. Theta is the angular displacement of the pulley. Right? What is the linear displacement of the spring? It is also r theta, because it moves like this. What is x? It will move by a distance of x when the mass moves x. So what is x? R theta. So therefore x is also having a displacement of r theta. Right? Any doubt? Shall I proceed to next problem? Take down. Find the natural frequency of the system. Find the natural frequency of the system. Find the natural frequency of the system. Right? Take down this problem. It is out of focus. 1 second. Now?
Okay.
Oh. It should be. So, in the figure, you can see that there is a pulley, okay. Over the pulley there is a mass m tied by this string. There is a spring, okay, fixed at a distance of r from the center of the pulley, small r, okay. One end is fixed and the string is at a distance of small r from the center of the pulley, and this string is carrying what? The mass m. The radius of the pulley is capital R. It is capital R. So now also, even though he has not mentioned that we have to consider whether we have to consider the mass of the pulley or not, but it is better to consider, okay, the pulley also and solve the problem, right? Fine. The similar way, similar to the previous problem, we will solve this problem also. As usual, our problem starts with energy method. That is, we know that, write down the solution. We know that by energy method, what is that? Potential energy plus kinetic energy. Okay. What is that? Is equal to constant. Right? This is our equation. Now, we will write the kinetic energy of mass, okay, and kinetic energy of the pulley. We always consider this as 1 and this as 2. Now we write kinetic energy of mass 1 of the first system, that is what? Half mv square. As usual, it is half mv square. Next, which is nothing but what? Half m. Okay. What is v square? What is v square? It is x dot square. It is x dot square. Then I will write that m is equal m. So x dot is equal to what? R theta. X equal to r theta. Why? When the mass is displaced by a distance x, then the angular displacement of the pulley is, what is the radius of the pulley? It is r. So angular displacement of the pulley is what? X equals to r theta. See here, r is what? The radius of the pulley. So therefore, x dot is what? R square theta dot square. R square theta dot square. Right? Now, call this as equation 1 as you, in your previous problem here also. Now, kinetic energy of pulley, what is that? Half I omega square. What is I? I is mass moment of inertia of the pulley. So this is nothing but 1 by 2 I. Okay. Omega square. That is what? The angular displacement is theta dot square. Angular displacement is theta dot square. Right? Now, half I theta dot square. Call it as equation number 2. Potential energy of the spring. Potential energy of the spring. Now you tell me, the spring is fixed at a distance of r. So therefore the linear displacement of the spring is equal to what? X equal to r theta. Because it is fixed at a distance of r. So therefore x equal to r theta for the spring. Fine. So therefore half kx square, you know this one, why we write this? Half k, what is x now? R theta. X is r theta. So therefore r square theta square. Call it as equation number 3. Is that clear now? So half kx, x is equal to what? R theta. It is not capital R theta now. Here it is small r, because the spring is fixed at a distance of radius r. So therefore r square theta square. R square theta square. Is that clear? Any doubt? Okay. Now you know all the three. Okay. Kinetic energy 1, kinetic energy 2 and potential energy. So we will substitute in that equation. Okay. Substituting equation 1, 2 and 3 in this equation.